Hello, in this video, I will explain how I improve the performance and assess the fit of my classifier for the bank marketing prediction test. My final model achieves an RCAC of approximately zero point 0.8 on the Kaggle leaderboard. I will walk through my notebook step by step, covering the first what I did to improve performance and then what I did to assess and improve the model fit. I start by loading the training and test data directly from Google Drive using Pandas and importing all necessary libraries, including NumPy, sklearn, Catbox, LGBN, XGBoost, and Spicy. The training test contains about um, 37,000 observations with 16 features, and the text has 8,000. The target has an 11.7% positive rate, meaning the dataset is quite imbalanced at roughly 7.5 to 1. Before building my model, I performed a thorough exploratory data analysis and I visualized the target distribution, plotted numeric histogram split by target, compute positive rates for each categorical level, and generate a correlation matrix. This EDA reveals three dominance predictors. First, the outcome equals success has 65% conversion rate versus the 9% baseline. Secondly, the miles show extreme seasonality, like the March, December, September, and October have 40 to 50% conversion, while May converts at only 7%. And third, the days recent matters and the client's contact within 90 days covers at 35% versus 9% for those contacted. The first major improvement comes from the feature engineering dictionary engineering driven by these findings. I replace the string unknown with none so capitals can handle missingness nativity. For mouse, I created sine and cosine sequence encoding so December's and January are neighbors. For balance, I applied a sine log transform and created binary flags at key thresholds. For ages, I add square term and flex for young and retired clients. Um, the log transform can page counted previous contacts and predates and create a contact efficiently visual. I also built a depth count composed from housing long and default indicators. Critically, I add interaction features motivated by the EDA, balance log times, predates, contact capture, and combination of values and reasons. Product success times balance positive identifiers, period success for high balance signs. I also build a vision not bad flag edge, time balance and other courses. Finally, I create a combination column like job metro and education for richer target encoding. In total, the pipeline produced about 45 features. The second improvement is the per-fold target encoding and frequency encoding for each of 9 encoding columns. I apply smooth target encoding with a smooth factor of 20 inside the course validation loop. The validation for analysis is on the target information which present the data leakage. I also apply frequency encoding to 6 main category columns. The third and most important performance gain comes from the 5 model ensemble with multi-sense cost validation. I trained 5 gram boosting model performed 2 cat models, 1 deep with steps, and 8 and moderate regulation, 1 shallow with steps, 2 heavier regulation, and differences. 2 light GBM models, one with 1 to 7 lives, and one with 63 leaves, differences in visualization, and one XGBoost model with step 7. CatBox uses native categorical features while Light GBN and XGBoost leaves label encoding categoricals. All use 4,000 maximum iterations with early stopping at 200 rounds patents and a learning rate of 0.05. The key of innovation is multi-seed series algorithm. Instead of 110 for where I run entire pipeline, this 3 times 6, 42, 2024, and 888. Each seeds produce different fault boundaries, so the model sees different subset. The test prediction from all three rounds are average. This is similar to 34 cost validation with independent space, and it's the most reliable variance reducer. This allows contributions roughly 0.001 to 0.002 AUC improvement on the leaderboard. After training, I compared four versions strategies and automatically select the best. The first rank a variant averaging with equal weight, second optimizing the probability rates while accessing netto made on OOF AUC, third optimize rank weights, which is the more naturally for AUC since AUC depends on ordering, no calibrating. Fourth, a stacking meta leader then the real 5 OOF vector become features for logistic regression. The notebook evaluates all four and picks the winner. I also apply for passive labeling using rank average tax predators, identify the top 4% as precious positive and the bottom 4% as a passive negatives. Those are added to training data and we train 5 models, 3 live GBM and 2 XGBoosts with different seeds. The final submission below the base ensemble 88% with specific label prediction at 12%. A conservation ratio is to limit the noise. So I tracked the per AUC all 5 models and visualized in the bar chart. So the single fault is dramatic outlier, conforming consistent generalizing. And so also point multi-C stable, showing each model AUC. Early stopping is active on every model with 200 rounds patients. And most people start between 800 and 1,500 iteration. Well before the 4,000 maximum, this confirms that the learning rate and regularization are well celebrated. Edge models also use multiple visualization machines. Cables use L2 leaf visualization, back-in temperature and weather strength. Light GBN use L1 and L2 penalties plus subsampling. XGBoosts use lambda, alpha, and subsampling, all prevents the trees from memorizing the noise. In summary, I improved the performance through 5 strategies: data-driven feature engineering, focus on 3 strongest EDA identified predators, perform targets encoding to prevent the laggage, a diverse 5 model ensemble with catballs, live GBN, and XGBoosts, multi-seed CV averages as single modes, impactful techniques, and full function fusion strategy with personal labeling. I assess fits through satisfied tenfold CV with 3 seeds, portfolio usage tracking, a leafing curve, early stopping with 200 rows, patience, regulations on all models, and ROC, precision, recall, and confunction, metrics evaluation on other fold prediction. The final pipeline achieves also approximately 0.8 of our COC. Thank you for watching.